Okay, everybody, welcome to section 5.6. Let's talk about these graphs of these other trigonometric functions. And I start a little bit backwards. I actually work with secant and cosecant functions first because, well, basically they're most closely related to the cosine and sine function, respectively, that we deal with. And that actually answers this first question that I've got for you. It says, why are the domains of the secant and cosecant functions restricted? Well, the answer, of course, is that when we talk about a cosecant of x function, for example, cosecant of x is defined as 1 over sine of x. And the thing that restricts the domain then is that whenever sine of x is equal to 0, we're going to find that cosecant is undefined. So that's the first question answered here. It should say is undefined. We'll go with it. It works, right? You can read that. All right, how about the other one? What about secant? Well, secant of x, of course, is defined as 1 over cosine of x. So if I'm dealing with 1 over cosine of x, of course, we would say that at any place where cosine of x is equal to 0, the secant function is undefined. All right, so this is going to help us determine something about the domains and ranges of these cosecant and secant functions. So if I have a function like f of x equals cosecant of x, what is its domain? The cosecant of x is defined at 0 whenever sine of x is equal to 0. So let's take a look at sine of x. If you recall, sine of x is the kind of function where if we were to plot the values at which it's equal to 0, we would see values like the following. Sine of x is 0 at 2 pi, at pi, at 0, and if we went off into the negative direction, we'd say negative pi, and so on. Right? So the domain for cosecant of x would be those values that sine of x is equal to 0. So for my domain, what I might write here is that domain, come on, Professor Peoples, is going to be the set of all x such that x is not equal to numbers like these, negative pi, 0, pi, 2 pi. And I'm just going to go write it this way for right now. Say, well, all right, we would include 0, we'd include pi, we'd include 2 pi, and so on. And so my domain is restricted as values that cannot equal this. And of course, for the range, since we're talking about an inverse of the sine function, the sine function had a range that went from -1 to +1. But cosecant is the reciprocal of that. So cosecant can't include anything from -1 to +1. So we're going to write this. For its range, it would go -infinity to -1, including 1, but not include anything between -1 and +1, and then go 1 to infinity. All right. Similar thing for secant, right? We think about how it's related to cosine. So if we know how the cosine function looks, we can graph this. So I've got y equals cosine of x. Its graph looks something more like the following. We see that here's 2 pi. Here's pi. It's defined slightly differently. Here's 0. Our asymptotes occur at pi over 2 and 3 pi over 2, right? These are the zeros, or at least 2 of the zeros of the cosine function. If we went over to negative pi over 2, we would find another one. So if we think about the domain of the secant function, the domain would be defined by the set of all values of x such that x cannot equal numbers like negative pi over 2, positive pi over 2, right? We can have 0 in the group, right? That's okay, right? It's just pi over 2. This is where cosine is 0. And 3 pi over 2. And if we continue on with this same pattern, we're going to continue to find all of the points where the secant of x is undefined. As far as its range, it's exactly the same as what we said about sine. So our range would be the set of all y values from negative infinity to negative 1, union with the sets from 1 to infinity. That is, everything outside of the range of cosine. All right, so this sets the background for graphing our secant and cosecant functions, and we'll go through a couple of examples with those. The message here, though, is that, well, if you want to graph a secant or cosecant function, then we're going to base what we do on what we did with sine and cosine, which is what makes this a little bit easier to handle.